Okay, now we have to interpret this data. We in the last session we did between correlation, and then we started with the linear regression. Linear regression is there is a prerequisite of it that it should satisfy the first, it should be correlated, and there should be a linear relationship between them. Okay. Next, now we have to see that what is the relation. Okay, now we are seeing that. It's saying that your mean weight, and this is the descriptive statistics table. Simple. It's showing you the means. We will be describing each of the tables, so, and then I will let you guys know how you will write this data in your result section. Okay, that's why I made a separate video of this because I want you guys to know and the stuff also. So here we have the mean. It's showing me that your mean is 13 and mean weight is 61. Okay, and the standard deviation also. Then it's showing me the correlation that your pain and weight are positively correlated, and there is a weak positive correlation that is zero point 0.4, and but it is significant. Its significance is more than less than 0.05. Okay. So I can write this first in my interpretation that there was a positive correlation and it was significant. Next thing I have this stuff. These three tables are the most important one. Coefficient, ANOVA, and model summary. We can remove this one. It's not of concern to us. We can also be not be concerned with the collinearity diagnostic and also not these. Okay, so these three tables, model summary, ANOVA, and coefficient are important for me. Okay, first I will look here in the ANOVA. It is less than 0.05. Our regression model is significant. So if our regression model is significant, our whole result is significant. There is a significant positive correlation between weight and pain. Okay. If your weight is more, you will have more pain in your joints. Okay. Now, still, I want to see that how much weight increase is causing the increase in pain. Okay. Some other variable that we will be extracting from this is first, I will be reporting this data that my ANOVA came out to be significant. I like this. I have to report this value that is a F value. Okay. And also, I will be reporting this R square value. Okay. And this one, the R square value that is 0.221. Okay. Now I will explain this that what does this R square value mean? And also the coefficient, that is, we will go for the unstandardized coefficient, that is 0.97. Okay. Okay. So now let me show you guys how to report this data. Okay. So the R square value that we saw before, that shows the effect of one predictor in the presence of the other predictors and tell us what percentage of the variance in marks can be predicted by the odds studied, that what percentage of weight gain is causing the pain. Okay. And interpretation is here. Okay. The independent variable significantly predicts the dependent variable. Let me take this whole in our Word document so I can better explain it to you guys there. We will be pasting it here, and this is the interpretation, and I will also be copying these tables, these three, to better explain my data. Variables entered, we don't need this whole. Okay, we will be needing only these tables. Okay, so I have got these three tables here, and now I will write the independent variable that was the weight. The weight of the people significantly predicts the pain in joints. Okay. And what is F? That is this value 13.875. And these values are are the degrees of freedom. Okay. We discussed this beforehand also, 1 and 49. I will replace this 1 and 49. In the degrees of freedom, we write them in the brackets. And this was F value is, this is a statistical value that is 13.875. Okay. And P is less than 0.05. How much is the significance? That is 0.01. 0.01. It indicates that the number of hours studied has a significant effect on the marks obtained in exam. It indicates that the weight of people has a significant impact on the pain in joints. Now, my question comes now again, how much is the effect? Okay, so the r square value here, the r square value is 0. You can even use the adjusted r square value. You can use the r square value. I think so. We should go for the adjusted r square value. Okay, 0.205, which means that the model explains 20% of the variance in pain in joints. That means that the change in weight has 20% effect on the pain in joints. Still, our data is not yet cleared. Okay. From this model, the model summary, we just need this adjusted R square value and F is same, degree of freedom is same. Okay. So we have analyzed this data. We will be removing it from here. We don't need it for now. Okay. And I have also explained this data. I don't need it. I'm just clearing the data sets because it's just making me confused. Okay. Now further explanation that how much we have explained about the variance, 20% of the variance is caused by the weight of the pain in joints. Now the only thing left is the unstandardized beta coefficient value, that is 0.97. That means that 1 unit change in weight leads to how much change in the dependent variable leads to 0.097 unit change in pain in joints. So now your data is perfectly analyzed that how much is the relationship between the weight and the pain. Okay. And this table you will also be adding in your results portion of your manuscript. Here we will write about the regression weight. How much was it? It was 20% variance. And what was the unstandardized coefficient value? 0.097. What is the R square value? That is 0.205. What is the p value? 0.001. And what is the hypothesis that the weight gain is leading to increase in pain in joints? One left is the F value, that is 13.875. Okay. So this is how you will be writing your result. You can get this whole interpretation even from my slides, or you can even you can check it from Google. Okay. So I hope you guys have understood the main things. In the next one, we will be looking at the linear regression, logistic regression.